Did you see?
Yes, if you just go full screen.
Yes.
Perfect. Thank you. Please begin.
Yes. This is my structure presentation. So we can go to that one, this presentation. Yes. First of all, can you hear me?
Yes, we can hear you.
Yes. First of all, Mozambique is one of the countries most affected by extreme events such as cyclones, floods, and droughts. The availability of timely hydrometeorological tools and data is extremely important for better monitoring and consequent decision making. So this is one of the reasons we have a flood and drought monitoring center in Mozambique. So this center is a standalone organization within Denjeraga, is a director of water manager resource for data collection and manipulation, analysis, forecasting, and dissemination of information related to flood and drought risk. So the objective of this organization is improve the management of extreme events. And the specified objective is predict rain and the main river basin, monitoring extreme events like a cyclone, floods, and droughts, produce maps or flood areas, and monitoring flow rain in the main river basin. First of all, we have this platform. This platform, the name is called GeoNetCast. So GeoNetCast is a global network of satellite-based information dissemination system that provide Earth observation that data and product. So this platform combined with other tools like satellite-based estimation of weather and climate data, precipitation forecast data, allow monitoring of weather events such as cyclones, and satellite images of the Earth surface. Next one, we have a global structure. Global structure is a global flood RNA system. So it is one platform of what holds one model meteorological. It is hydrological with objective into supply alerts. It is forecasting in floods the level worldwide. And this system allows to obtain data historical correctings from forecast flow rate, estimate the condition from humidity from soil, and to do forecast season aligned areas in inundation. So next one we have HMS. So HMS is a hydrology modeling tool that enable the tireless simulation of hydrology process in river basin. So we have Acras. Acras is a versatile tool that provides a platform for simulating and analyzing hydraulic and the hydrological process in river system. Next one. In this point, we have a dissemination of results and activation of the early warning system. After collecting all the data within this platform, we can have dissemination of results, and the activation of the early warning system is done through the publication of bulletin, publication of information within other administrative authorities like that and media social. Next one. We can conclusion. GeoNetCast and Globus are two tools that play an important role in hydrometeorological forecasting and mitigate the effects of natural disaster. The GeoNetCast monitoring approach meteorological events like cyclones and provide geospatial data, allowing for better understanding and response to extreme events. So Globus is a tool that allows flood forecasting and mapping of flood risk areas. So we have here a way forward. The flood and the drought monitoring center. We have here a early warning system. So this system is a bank installed in this center monitoring at Directorate in Mozambique, and it will be tested in the present rain season. It is expected that the center will also host the flood early warning system of the Bopuza and the Inmakon and Zamcom in the near future. So this is the presentation. Thank you for the opportunity to show what we do in Mozambique.
Many thanks, sir. We're going to have you stay on the presentation so that if there's any questions at the end, they can be put to you. And now it's Dr. Modathir.
Thank you.
Excuse me, can you repeat your question?
Yes, if you'd like to stay on the session for us, just in case there's any questions, we're just going to go to the next speaker.
Good morning, everyone. My name is Modathir Zaroug. I work at the Nile Basin Initiative Secretariat at Entebbe, Uganda. So today I will share with you the regional early warning systems that we have at the Nile Basin. Thank you. This is just like the first slide, like brief information about what is the Nile Basin for those who are not familiar with the Nile Basin. So our shared vision is to achieve sustainable socio-economic development through the equitable utilization and benefit from the common Nile Basin water resources. And we have three core functions: facilitating basin cooperation, and water resources management, and water resources development. We have three offices. The Secretariat, it is at Entebbe, Uganda. We have also an office in Addis Ababa, Ethiopia, and another one in Kigali, Rwanda. And this is the MBI strategy, like 2017, 2027. And these are the key areas and key goals. The first one, it is like water security. And then the second one, it is about the energy security. And then we have also like food security. This is goal number 3. We have the environmental sustainability, and goal number 5, it is climate change adaptation. And goal number 6, this is strengthening transboundary water governance. That is the map for the Nile Basin, and these are the countries. If you are familiar with the countries: Egypt, Sudan, Ethiopia, South Sudan, Uganda, Kenya, Tanzania, Rwanda, Burundi, DRC. This is just quickly one of our tools for this early warning system. And we normally focus in simplifying our tools for our stakeholders in terms of registration and accessibility, and also to tailor your own information. So it is a simple tool, accessible for everyone. Anyone can register. Even here you can register and you can access. Just select Nile in the default. And here, as I mentioned, the learning curve to use this tool, it is not steep. You can quickly select your parameters or indices and generate your own information. And here we are looking, because yesterday there was a question about we want to tailor the information at the national level. So we want to tailor our own information, and the stakeholder want to tailor his or her own information and generate the information that they want in terms of graphs or tables or statistics. And here we have like 198 variables and indices in this tool. 15 of them, they are like forecasted variables. And if you can see here in this plot, these are the 10 large subbasins. So if you want to tailor your own information in these 10 large subbasins, you can tailor your information, because normally we work with like NetCDF files, and this irregular shape file, you want to generate the graph in this irregular shape file. You want to generate your own tables or your own statistics. So you can do that for these 10 large subbasins. We also went more for defining the small catchment. And this catchment, we define them based on like extensive stakeholder engagement. They are interested in this catchment. So our stakeholders, they can generate and tailor their own information in this small catchment. Also, we selected some points with our stakeholders. They can also pick and generate the information in those selected points. And also, if the stakeholder want to select his own point and then generate information, it is also possible. So in these different catchments, you can overlay them. And even in the points, you can overlay them. You can display one of them. You can display many of the graphs. You can look at the average with like the interannual variability. These are the tables that you can also generate These are the envelope graphs for those who are looking at forecasted information. We also issue like a monthly bulletin, and we share it with all our stakeholders in the basin. This is another tool. This is like also flash flood tool, because our stakeholders, they say they want also more information about the flash floods, and specifically in some hotspot areas. So here you can see like some of these hotspots, and for our stakeholders also, they can, we are finalizing this activity by this month. So they can generate also their own information in some key hotspots. And here for some of these variables, there are some thresholds for very high or something like mild. And they can generate their own graphs and download and use those graphs. This is another example, like for example, this is the GFS, the forecasted rainfall data. It is also available, one of the services that we provide through our portal here for the flash floods. We have like another project in the Eastern Nile. This includes Sudan, Ethiopia, South Sudan. And here also in that area, they are interested specifically to see the flood and the forecasted rainfall in that area. This is also another project and focusing 4 sub-basins, Lake Tana, Barakobo, Sobat, Blue Nile, Takaziat, Barak. These are like 4 sub-basins with extensive information. This is another tool. This is our Nile Basin river flow forecasting system, because we are interested also to look at the flow and to look at the forecasted flow in 80 selected points. We selected with our stakeholders 80 points, and we want to look at the flows at those points. We also want to look at, we have many large dams in the Nile Basin. We want to look also at the forecasted water levels in that area, and plus also several other information. They are also available. We finalized this project, but we found that it needs like more refinement. So we are working now in the second phase to refine this project, or this operated system. This is the last thing. We have hydromet system centralized. We have another expert at NileSec. We can see the flows in each point. And when we receive any kind of information that there are some kinds of flood here or there, we look at our system and we can immediately check the water levels here. This is in the past few days, some kind of flood in East Africa. In some area here also, this was a flood also. This is also another station. We have many stations, around 67 stations distributed along the Nile Basin. So we are monitoring daily what is happening over the Nile Basin. This is real-time information. This is also one of the tools to confirm the status of what is happening on the ground. This is the last slide. It's about some few recommendations. Simple forecasting tools should be maintained and updated to meet the stakeholders and decision makers' needs. We work closely with our stakeholders and we work with the ministries of water resources in the Nile Basin. We work very closely with them. Also, we are very much interested in the capacity building and to capacitate our stakeholders in the region. That is very important. And the dissemination, this is also very important to disseminate the information that we have and to disseminate the tools that we have for our stakeholders. Thank you.
Thanks, Modathir. And we have one more presenter who is Thokozane Malibe. I hope I spelled that right. Apologies if I haven't. And again, they are remote and we are now getting ready.
Would you be able to share your screen for me, Thokozane? And unmute your microphone as well.
Yes.
Perfect, thank you. Perfect, brilliant, you may begin. You can make a start if you'd like, we can hear you.
Sorry, I think sorry, Kate, I think I'm playing the wrong presentation here.
Are you able to share your screen for me again? Okay.
Yes. Can you see my presentation?
Yes, we can. It looks great. Thank you.
All right. Thank you very much. My name is Thokozane Malibe from the Inkomati-Usuthu Catchment Management Agency. I'm going to present on decision support tools for effective management. And this is a case study of Inkomati-Usuthu water management area, South Africa. Maybe to give
sound, so I may play the video instead, if that's okay.
Sorry. Hello? Can you hear me?
We're having some problems with the connection and the sound, so we got a backup. We asked everybody to record their presentations just in case this happens. So we're going to take the response.
Okay.
Play this video. Catchment Management Agency. I'm going to present the decision support tools for effective plant management. This is a case study of Inkomati-Usuthu water management area in South Africa. But to give an overview of the Inkomati-Usuthu water management area, there's four main rivers which form the subdivision into four main catchments, and those are the sub-sediment, the upper part, and from the Nile, then the Inkomati. Now the Inkomati, for the purpose of this management, is divided into two parts. To the upper Inkomati, which is upstream of the Basin, and the lower Inkomati, which is downstream of the and last but not least, we have the Usuthu catchment.
apologies for that. We were hoping that the quality would be good enough, but unfortunately, I think we're going to leave it there. We do have all three presenters here, though, if you have any questions.
Presentations, I'll put my website as well.
Or any presentations will be available online when the quality is. Any questions? If not, yeah.
Oh,
Sorry.
Yeah, I think the pity we lost the director for this last one. I just wanted to find out in terms of the system they use. You know, if it's able to detect the water quality from different points. And again, I saw in the list of the stakeholder, there was no organizations like the AgriSita, which does. AgriSita is it's an authority body that deals with capacitation and training. I see it's not in the list. So, yeah, I wanted to ask that.
Is he able to do that?
yeah.
I see.
Thokozane, could you
Maybe somebody.
unmute for me just to answer that question?
Sorry, I didn't get the question. What was the question?
Oh, and the question is with regards to the water quality and the system you use. And I was looking at the river network, especially the crocodile. I know most of the water from the crocodile travels distances and distances. Somewhere is the pollution from agriculture, somewhere is pollution from domestic use. Are you able to detect that, and how do you feedback to the source of pollution to say, be careful, at this point, the quality is compromised?
Did you hear that okay?
Yes. Thank you very much for that question. For now, unfortunately, we do not have a real-time water quality monitoring across the entire catchment. But what we do, we take we take monthly samples and then we send them to the lab for analysis. It's so unfortunate that there will be that lag time between when the incident pollution has been reported and the time it actually reaches the downstream reaches. But for some of the pollution incidents, like for example, if there is something that like for example, if we have an oil spill, as an example. So that is an incident that can be reported on the spot, and then we inform the people or the authorities downstream to be alert of such a thing while the cleanup is actually taking place. So in terms of the real time, for now we do not have, but there are plans in place to actually do the installations for the water quality instruments to actually do send us on real-time basis. Thank you.
Thank you very much. Any other questions? No? We'll move on then to break time. So our next session is at 11:15 here, and our technical session will begin. So please go outside.